Okay. What a harrowing opening to this stream. I came up and down like 5 times. I lost my configurations for things. It's all good now, but I think the VOD for this stream may be misnamed also. I'll worry about that later. It's fine. Getting started a little late tonight. I think the main thing I want to do tonight, because it won't take that long, but it'll still be pretty involved, is kind of taking another concept that I've seen in JAI, Jonathan Blow's language, is so for structs, for example, I think I'm going to let you do this for anything that is a declaration. So a struct, a variable, a function, whatever is a decal, you will be able to add tags. So I'm thinking something like this, or maybe this, tags, maybe just tag, and I don't know, you'll be able to say like custom, comma separated list of tags. And then the metaprogram, when you are looking at these nodes, any node that you're looping through in the metaprogram, you can query its tags. So this is just a way for you to communicate certain functions or declarations as like, you can communicate special information to the metaprogram to do extra things with them. Normally, like, you could encode this into the name or something, like, but that's want something a little more robust, so that's what we're doing. So I think first thing I want to do is decide if this is going before or after the before or after the semicolon. I guess it can go after because it looks kind of like a pre-proc. So actually, first thing I will do is update my version of forecoder to syntax highlight this. And I do that, I just have a tiny little custom layer in forecoder. I can add custom pre-procs and custom keywords for highlighting. So I'll just add another one here. I guess I will commit to calling them just tag instead of tags. I guess I don't know what I would prefer. Like, does this look weird? Tags, if there's more than one. I think tag is fine. I'm not going to worry that much about it. So tag, there we go. And now we can recompile the forecoder custom layer. We will go to, now I don't know if it was on my laptop or on here that I set up a helper script for this. Do whole thing, it's on here. Let's close forecoder, let's run this. Boom. So open forecoder back up. Let's make it big so people can see it. And let's open up our project. And if we go back to main, I should be able to now tag this, and it is highlighted. There you go. Tag v2, custom, like whatever you want. Easy to do. So let's go to the parser. And we are going to add a new thing to the node here. I guess tags can just be strings. Like, is there really any reason for them to be anything else? I don't think so. So on the node here, we will have a new array. I guess it'll just be arbitrary. You'll just have a certain amount on there. Well, actually, no. let's not do that. Let's actually store num tags and tags. So this will just be a dynamic array. No need to waste more space than we need to if we can just throw it on the parser's memory arena. So tags. Okay. We are going to go to the parsing code. Now, how do we want to do this? It's after a decal. Basically, any decal that we parse. Do we have an easy way to see where we parse a decal? Here's something I can do. Let's say let's do this on the parser. Let's have a synthetic node cache size of node. Am I using that anywhere? Yes, I am. Okay, we will do I guess we'll do like last node parsed and create node. I don't like that though, because there's a lot of places where nodes get created. Why don't we... Well, first of all, okay, before we do this, let's lex. Let's start there. Let's actually lex this thing. Probably should have started there. Token any of type represents custom directive. Sure, let's add another one. Tag. And let's add tag. Okay. So in the lexer, a new where do we do that at? Preprocessor directive. We will say okay. Let's not do this. Let's actually say that this is a custom keyword. Let's have a custom preprox. Although we have other custom ones that we don't put here. You know what? It's fine. We'll just do it the way I'm doing these other ones. We will have another one in here that is explicitly handle the custom tag directive here. If it's tag, we will add tag, skip ahead, and keep going. That seems fine to me. Do we have a tag in here? Did I remove it? I did, so this should be fine. Okay. And now, if I add a tag like here, it should not know what to do with that. Oh. Do we have an expect? No. There should be a colon after. Oh, the parser takes care of that though. Okay, we're fine. This should not know what to do with that. Unhandled token tag. So we don't currently know how to parse that. We are lexing it though. So in the parser, see, that's the thing. We need to know what the last thing we parsed was. The last node. I feel like this is going to require more substantive changes to the parser than I was anticipating, which is fine. I just need to know where this is going to go. Because there's basically two ways this can go. I can either find every place where we add a decal node to the tree and insert a function call that handles tags if they see tags. Or I can do the tag handling generically here like I do for other preprocs. And I just do it always if the last thing we parsed. I have to keep track of the last thing we parsed though. And if the last thing we parsed was a decal, then I can do that here. Keyword. Do I do where do I do snippets and stuff? Custom keyword, token snippet. Wait a minute. Oh, that is just a custom preproc. Okay. Token any. Token ellipse. Token type. Okay. I'm a little confused why we don't parse these down here, but I guess that's okay. I feel like it's probably better to do it after every decal. So let's just start with this struct decal here. We're gonna say parse struct. Parse struct. So at the very end, when we're done parsing a struct, right, we return the struct node, parse struct. Let's do it there. So before we return the struct node, we are gonna write a handle tags, handle potential, parse potential tags. We're gonna pass it the parser. We're gonna pass it the node. And I guess that's it. We will go up here and say, where's our first parsing thing? Create node, create child node, add child node. Where do we start parsing things? Create decl ref node, parse string concat node. So right here, we will just do a void parse potential tags. It will take the parser, and it will take the parent node. Okay. We will expect token. Will not expect token, because this crashes us, don't it? Yeah. We just want next, let's just peek the token in the parser. If next type is not a token tag, then it's fine. We're good. We don't have to do anything. Otherwise, oh, but wait. Is this skipping over the closing semicolon? Because if it's not, it's not. How many times do we call parse struct? This is going to be gross, and I don't like it. I guess the alternative is tags go before the semicolon, which also feels gross to me. Like instead of this, it would look like this, which, I mean, I don't know. Functions don't even have semicolons, so maybe it's not that bad. It will save me having to gum up the parser a lot. You know what? That's fine. I don't care. I've decided I don't care. Oh, but wait, I do care, because in decls, that's going to do that to our decls, our variable decls, instead of this. Oh, also, since the parser doesn't care that these things are on the same line, it also means you could tag them like this. Right? If you put it past the semicolon. Yeah, I kind of want it to be past the semicolon, if there is one. This is... Okay, let's look here at all the possible decls we have here. They are variables. I guess you could tag a parameter. I don't know why you would want to. Struct members, yes. Union members, yes. Enum members, yes. Bit field members, yes. Functions, yes. Structs, yes. Enums, yes. So there's not that many of them. Tracking those down and making sure that there are tags on all of them is not the worst thing, I guess. Let's just do it that way. So potential tags, this is not going to go here. Parse struct. So this is when you're in a union. That's not what I'm looking for. So here's the first part. If there's a struct node, yeah, skip the semicolon if there is one. Then we parse potential tags. Right? Parse struct, and we can do that here too. Skip the semicolon, parse potential tags. Sure. Substruct is Right, so this would be substruct, I think, because no, this would be you know what? Here's what we'll do. Assert message false. How does parse potential tags interact here? Yes, I punted this for later. Sorry. I'll just come back to that. I don't feel like thinking about that right now. So parse potential tags. Okay. The next thing's not a tag, we don't care. Otherwise, skip the token. Advanced token parser. Next equals peak token parser. So the next thing we expect on identifier is what we expect. Expect, do I have an identifier? Nope. Identifier. Oh, it's a preproc identifier. Let's see if that's actually what that is on the tree. So assert, no, expect token parser. Next, we expect a token identifier, token tag. Let's do that for now. No tags yet. So, cannot convert. No, this is a. I did not add the tag here. It's a preproc tag. It's a custom directive. Same thing here because C can't do that for you. Okay. So expect a preproc tag. No. Oh yeah, that's the context. Okay. This should be fine. Nope, we freak out. That's fine. Why do we freak out? That's strange. Nothing changed here. Parse potential tags. I'm not. Oh yeah, I am. If I just remove that. Okay, that's weird. That function already failing. If it's not a token tag, which it's not, we just return. Parse potential tags. If the next is a semicolon, which it is, we skip the semicolon, and then we parse potential tags. How is this already failing? We look at the next thing after the semicolon. If it's not a tag, we bounce. Am I already gonna have to open Visual Studio? Really? Print. Do I have a way to print out tokens super easily? I haven't messed with tokens in a long time. Print tokens. Print the tokens. Print known macros. Okay, I guess I don't have a good way to do that, so we'll just write output lexer token type strings next type. Okay, that's fine. Okay, we found a keyword, identifier, 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 identifier. So that would be here, identifier, keyword identifier. Oh, that's here. Keyword, wait. Do we ever hit that? No. We never once hit that. What is the problem? If not next, is that why? Let's just do this. Assert next. That's why we hit peak token is, oh, because there are no tags in here. We eventually get nothing back? How is that possible? Peak token should not ever give us back. Oh, grab next token error checking. I'm not doing that. Forgot about that. Okay. Grab next token error checking. And this should also be peak next token error checking. Grab next token error, peak next token error. Parse potential tags. Okay, this should be peak next token error checking. So pass the parser. We pass. This is dumb. Why is this not just a function? Am I wrong? Why is this not just a function? I'm a little confused why I did that. That seems like that makes that more complicated. So if not peak token parser, then we error on oh, because I wanted the current. Does parse error token. We'll say if token, then we'll put that in there. Okay, if there is no token, who cares? So we can say and here there do I want that complicates this whole thing. You know what? This is, I want to not have to keep track of this context all over the place, but this can be 0. The context, I mean, I guess it's fine. I just don't really care about it at all. I guess I do. I guess I do care about it. Metagen parser, no, lexer token. So it's going to return this. And in fact, let's do this. Result is this. If not result, otherwise return result. Okay, Potential tags. This will be peak next token error checking, and we're in tag. There you go. Oh wait, but that's just gonna error, isn't it? Oh, this is a oh no. This has to go below here. Peak token. This has to go down here. And next. 1978. You're right, that doesn't take that. I just declared. Unexpected symbol after online 5. What is it? Is that just because I just introduced this? It is. Unexpected symbol. This is next equals that. Duh. Okay, unexpected end of file. Okay, that's if it never finds one at all, which is really not what we're doing. I don't want to replace all my peak tokens with this, because if it's the end of file, because this shouldn't crash if it doesn't exist. So okay, we're going back to this, because it's not necessarily true that this is going to even have a thing. If not next, or it's not a tag. Great. Okay. That was more painful than it needed to be, but you know what? We're doing it. So, now, now, we don't see this at all, but if we have a tag here, tag, custom, we should see, okay, we should see tag, we skip over this, there should be a colon afterwards. Expect token, parser, next. We're gonna say next is peak token. The next thing, no. No. Type. We expect a colon. And finally, we expect an identifier. And really it's a comma separated list of identifiers, but let's start small. Next should be a comma separated list of identifiers. So expect an identifier next. This should just work as it is. Unexpected node type, declref. In global scope. Right, codegen doesn't know how to deal with the tags. Although, wait. Oh, is it because of that? Yes, that's why. Codegen sees a declref here and it doesn't expect there to be one. So let's add a property to that. We're going to take this one. Property tag identifier. Oh, we already took that one. That was a stale comment. Cool. Okay. This is a tag identifier, so although wait, that shouldn't be getting added to the tree at all. We actually, no, this is not the case. Forget what I just said. We expect an identifier, we need to just skip it. Duh. Okay, I was confused. Yeah, that shouldn't matter. We skip past it. That shouldn't even be showing up in codegen. Okay. But if this is a comma separated list of them, it's going to freak out. It doesn't expect a comma there. So, expect an identifier. We get one. And skip it. Then we say, we'll say a potentially comma separated list of, should be potentially a comma separated list of identifiers. Expect an identifier. Colon followed by an identifier, skip the colon. Okay, here's what we're gonna do. So now we know we're in a good spot. So count the number of comma separated identifiers tags are in the tags. So while we're gonna say next is peak token parser, while the next thing here's how we're going to do this. Grab the first one. So num tags is 1. Always. There's always at least one tag. And grab the token. Okay, we grab the tag. First ident. So we grab the first one. Now we look at the next thing, and as long as there's a comma, we eat the comma, grab the next identifier, and repeat until we don't see a comma there. So while next type is a token comma, we will eat it, and we expect a identifier again. Grab the comma, expect an identifier, grabbing it if, counting it if true. And actually, I don't want to skip ahead yet. This is going to be I don't want to skip ahead yet because we're just counting them first. So here's a fun little trick. The parser over here, if you notice, it's just a bunch of pointers and some ints. So I can copy this parser and just get a copy of all these things. And since peeking and grabbing tokens is just moving us along the token cursor through the lexer, it's just kind of pointing us to the next one. I can very cheaply, like basically for free here, create a new parser copy, temp copy is I'm gonna make a copy of the parse that they passed us, right? And now all this work I can do in the temp copy. So I can skip tokens, I can do all that stuff and eat my way through what's coming up. And then I just don't have to care about the copy anymore because we're just using it to count things. So this is a very handy little thing to do here. So we will eat the identifier off the copy, and we'll do all the peeking here and the skipping on the copy. We expect an identifier. Advance and copy the tag. So we want to scout ahead and count tags. So let's do it on a copy of the parser to make our lives easier. You know what? I am too obsessive over that, but it's fine. So let's do it on a copy of the parser to make our lives easier. We grab the first one. There's one tag so far. We look at the next thing. If it's a comma, skip the comma. We expect an identifier. Skip that and count it. The next thing. Oh, and then, yep, then we have to look at the next thing. So that should tell us how many tags. So let's really quick output num let's print node nicely, parent node, and then tags int string num tags. Right? So we're just going to print out how many tags each thing we found was. And actually this is going to crash or loop forever because we're not actually skipping them here anymore. We are doing it in the... Well, okay, let's do this for real. Not on the copy, just for now, just so we can not crash and see that it worked. Temp copy with parser. So integer storage, it says has 2 tags, which it does. If I remove this, it has 1 tag. If there's like an error, like I put a period in here, it's like, hey, I don't know what that is, buddy. If I put a comma, it's like, hey, there should be an identifier after this thing. If there's no identifier, again, it's like, hey man, you told me you got tags. I don't see an identifier. So that worked. And we should be able to put this like on other lines too if we want. Right, and it kind of just works. So that's cool too. Let's put this back to temp copy. So we are now counting the tags. Now that we know how many tags there are, let's allocate them and hook them up to the node. So we have num tags. We're gonna say for tag ID is 0, tag ID is less than num tags, plus plus tag ID. I didn't allocate it first, so we're gonna say parent node, what did I call it? Just tags. Tags equals push array. This is going to be the parsers arena, and these are short strings, and there are num tags of them. So for each tag, we will we can just, we know how many tags we already counted, and there's always a comma after every one except the last one. So we can just say, for each tag, we will parent node tags tag ID. We grab the token, which which we know should be an identifier because of the work we did up here. We set ourselves up right there. We grab the identifier. We skip the comma. And you know what? That won't be the case for the last one. So we can either compare the number, or how about we just check? Wait. Oh, geez. Excuse me. Right. If the next thing is a comma, we'll just do it this way. We could do it based on the tag ID. If it's the last one, don't skip it. Or we can check for comma. It doesn't really matter. I'm just going to check for comma. I think that's it, actually. I think we have tags now. Oh boy. Short strings, that's not a thing. Grab token. Oh. I want the text. Get token text of grab token parser. And peak token, nope, this is the type of it. Okay. We don't crash. We've got tags here. Now let's just see if we can print them out. When we print the AST, let's go ahead and print tags out in the AST, just for the hell of it. It's only on structs right now, so structs, verbose. Do I want to see tags? Let's write a helper void print tags on a node for, oh, I did not set parent node num tags. That would have been dumb. Print tags. So for tag ID is no 0. Tag ID is less than node num tags. Tag ID. Write output node tags tag ID. And then if so here I do have to know if tag ID is less than node num tags -1. So if we're not the last one, we want to write a comma. Right? So And how do we want to display this? I guess between square brackets. I guess. It's fine with me. Actually, let's just be really explicit about it. We'll say tags, and then I'm not calling that. It helps to call the things that you're doing. Print tags. No, this is just node. Okay. Oh, I gotta print out the tree. That's not it. It's T. Okay, and then let's go to main. Does it really go off the edge? What? No way. It does. Let's print out the tree out here. And open it up in Emacs. Okay, main.db. Okay. This is on what? Integer storage. There we go. So, it's a metastruct template called integer storage. Here's its pointer. It has tags custom and v2. That's really what I wanted to do tonight. It wasn't so bad. So you can add more tags here. So another tag. Can it have exclamation points in it? No, because it has to be an identifier. That's, yes. Yes, it doesn't know what that is. That's fine. Integer storage. There we go. So it's got 3 tags in it. I don't love the way that looks on the output. How about we do print tags? How about we do this instead? And actually, can I just grep for tags? Oh, if not node num tags, and you know what? Let's do this. Num tags. If node num tags. If not num tags, return. And then this can all just be boom. That looks a little better to me. So name, here's the pointer, and there's all of its tags. Cool. So now your metaprograms, well, okay, I have to extend this to the other decls. Right now it's just structs, but that's fine. Other decls will be able to have this. In fact, you should be able to do this as well. Oh, can this have spaces too, right? This can just look as nice as you want it, and it should still work. Oopsie. It doesn't know how to do that yet. Yeah, okay, cool. That's really nice that you're not beholden to making that look ugly just to have this work. So, I don't know, like hidden, I don't know. You can just have a weird thing. So let's do that next. Let's say, let's go back to the parser. We're already here. Parse function or variable decal. Does this skip the semicolon? Return result. No, it probably doesn't. Parse function or variable decal. Does this skip the semicolon? What is this function? Parse struct. See, this is why I'm gonna have to call this on every place we parse a decal instead of doing it generically, knowing the last thing we parsed. Either way is kind of gross for different reasons. And I don't know what I want to do about that. Like, the way this works right now, every time in all these different places in this parser where I parse any kind of decal, I have to add I'm gonna have to add this call. That hurts future expansion. It is kind of gross. And I can't put it inside of like the thing that actually parses this thing, because this parser was built under the assumption that you can call this and it will not eat the semicolon. The caller has to do that. So this has to happen after we eat this semicolon here. The other way that I would do this is, instead of putting this at every spot where we would parse this, this could go here in like the master do parse function that's doing the whole thing. And it just always calls parse potential tags if it just finished parsing something. The problem with that is I have to know, this function has to know what node we're talking about putting the tags on. And currently, do parse is just churning through things. It doesn't care about what it just looked at. I don't know what the last thing we parsed was, like programmatically. If I did, which I started to do that over here, I started to say, so in the parser, I started to add this last parsed node or something. But then I have to go through the parser and add, update this. It's kind of the same problem from a different direction. Now I have to make sure the parser is updating this every time it parses a new node and adds it to the tree, which again makes adding new things more error prone. I don't like either one. This is one of those cases where if I was doing this parser again from scratch, like if I started over and tags were going to be in there from the start, this would be engineered a little differently. But it's fine. We will make do. We will say parse potential tags. Let's look at all the things that this could be on. Hey, you're doing a good job. Thank you. I appreciate that. Nice to see you, Tofu. I know you have been in before. I kind of took a small break from streaming, but I was doing it like nightly for a while, and then I kind of fell off a little bit. I'm going to try and get back to it. I'm enjoying this a lot, so. Okay. So, let's look at all the things this could be on. I said it's only going to be on decals, so let's do variables. Parse function or variable decal. Where all does this get called? Right here. Parse function or variable decal. So, right, this function could return multiple things. So like if you have a right, if you do this, this parse function or variable decal could return this doesn't just return a node, it returns a multi-node result, because a single call to parse on this would really result in 3 nodes getting added to the tree, 3 different variable decals. So this function is doing a lot of heavy lifting. It could either be a single function decal, a single variable decal, or multiple variable decals. So, does this skip the semicolon in any of those cases? Parse function decal. Function decal will not have a semicolon. So actually, in function decal, this will not have a... Okay, this is a case where I can do it right here. Parse potential tags. That's actually really nice, and it will do it on the function decal. So actually, so if I run this right now, let's undo this part just for now. Let's hold off on this. Ah. Okay. If I put this here now, func tag, does that just work? Well, oh, I'm not printing it for everything though. I think that probably did work because we didn't crash, so. But print tags, we have to do this on, let's just do this now. So unions will have it, structs will have it, type defs can have it, any decal really. Functions, bit fields, enums. What is this? Variables are kind of crazy right now. There's a lot that it could print, but at the very end, boom. Decal. So what else did we do here? Decal, decal, decal. Okay. Now everything prints it. We should see the function here too. Which we do. Sick. Okay. Great. That's great news. So functions. Let's do variable decals next. Let's uncomment this. And let's have that work. So oops, sorry, I just hit the mic. Parse variable decal. This I don't think assumes, or this I don't think skips the semicolon. Well, actually, does it really? Parse variable decal. Was it just structs that we didn't skip it on? So that doesn't. Well, that does, but it does it higher up. What is this? Parse variable decal. This is inside of, what is this? Function or variable decal. Does this skip the semicolon? No. Maybe that function does skip it for us. That would be really, really nice. That would make this a lot simpler. So parse function pointer. So this doesn't. You can see it looks... Oh no, it does. It grabs it. It does skip it. Okay, we can do that here. Great. This is awesome. Parse potential tags on the variable decal. And let's just copy this. So does this actually always skip it then? Can I just assume that this will skip the semicolon? Let's just put that here and just see what happens. If things break, then we can be more robust about it, but at the moment it looks like this might always just skip it. 2451. This is not... Oh. Right. Ooh, okay. If it's multiple nodes, if it's multiple variables that it's parsing here, like, again, in this case where, if it's this, so if I did this, No semicolon. All of these need to be, oh wait, hold on. For coder is going to make that gross. It does not understand that this. I think I can put a semicolon there and it won't bother it, but for coder sees that and it's like, I don't understand what you just did. So it messes up the syntax highlighting, or the syntax, the formatting. That's fine though. So if I do this, all three of these need to get that tag. All three of them. So, let's okay, you know what? Let's grab the first one. First is result 0. We'll grab the very first one and we will do this on the first one. And then result ID is 1 to what is this called? Result num nodes. We'll just copy them. We will say result ID num tags is first num tags, and the tags will be the tags. They'll just point to the same things. This is not, this is nodes. Nodes. Result nodes. Are these? Yes. Okay. We fail. On 149. Oh, I broke. Wait. Oh, we never get here. Okay. We only get here if it is a multi-result. Right? We break earlier if that's not the case. So, why do we do that, actually? Do we have to do that? No, we don't have to do that. Okay, that's, yeah, we don't have to do that. Because we're still setting result, and although here, we do have some early outs here. Okay, let's do this. Let's have a parse multi-result, multi-node result tags. It's gonna take the, do we need the parser? We need the parser. And we need the results. Grab the first one still. Boom. 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 So we grab the first one, we parse its tags, we loop over how many it got, update the other ones. Great. So here we will parse multi-node result tags, parser results. Parser results. Parser results. This function's only getting grosser, but sometimes it's just how it goes. Okay. Didn't rename that one. This is results. And none of those are results. These are all singular. Results. Result. we compiled. Let's see if we grabbed the tags. The struct template, integer storage, has it. The struct member, U64 size, has it. The function template, my function, has it. So, cool. Can I do it here? Let's do the exact example I said. Test red blue custom multi not custom. Look at that. Test red blue, 3 variables. They each have the tag on it. Why is that an error, though? Why are we erroring? That should still compile. That is a bug in the parser. Let's go see what it generated, because that should totally work. Aha. As you can see, there is a bug in the parser. It doesn't know, or not the parser, the codegen. It doesn't know how to generate that. That's weird, but hey, good thing I caught it. I don't really ever do this, but come on, the parser should be able to handle that. The codegen should know. And in fact, why is that erroring? Because we just saw that this shows up as 3 separate variable decls, right? Distinct. They are distinctly 3 different ones. Why are these missing their types? There are 3 distinct ones on the tree. That's actually really confusing. How did that possibly break? Append node as string. Yeah, like what? Well, I'm gonna examine that part of the tree more closely, because that doesn't make any sense to me. Red? Yeah. These are just 3 different variable decls, as far as I can tell. That should not be failing. Oh. Omit type if it's part of a multi-decal. Oh, okay. I must have changed this at some point. I think I made the decision, if you write out multi-decals like this, I think at some point I think it used to work, and then at some point I made the decision where this will actually generate this in the final result. It'll actually generate this. But because I never do it, I never saw that I messed this up. Whenever I made the decision to have it spit this out, I didn't update this to recognize that. So we never want to omit the type, like ever. We always want to print the type. Yeah. Let's put that back where it was to make sure that still works. Okay, we compile now. Unused variable, unused variable, unused variable, but they are in fact variables. They're all tagged. Great. What else are we missing here? Hi. Okay, let's look at the parser again. We have variables, functions. Those are just variables. Structs, unions. Nope, parser. Parse struct. What is this? This is parse struct. Substruct. Oh, this is my assert, right? Let's put this here too. In substruct. Yep. And yep. And here too. Skip, 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 skip. Let's put it in all four of these places. That'll be a future me problem, sorry. Parse struct. We do it here, I believe. Parse potential tags. Well, let's do it for the union. Parse potential tags on union node. Enums, yep. Let's parse potential tags on, let's save this node. Enum. Parse enum. Does that actually not skip the semicolon, or does it? No, it does not. Although we don't hear either. Do enums take semicolons? I don't even remember. What is wrong with me? Where do I use enums? Where's an enum? I need to see an enum. Oh, the parser. Duh. Yeah, enums take semicolons. Where am I skipping it then? Yeah, what? Parse enum. Curly, curly. Oh, I do. Semicolon. It's right here. Okay, so parse enum does skip the semicolon, in which case, this is dumb that this is different in so many places. Sometimes it's just how... Well, no, I don't know how it got that way. I don't like it though, but hey. It's fine. I don't like it. Parse enum member, so grab the comma or closing brace. So, do I want to be able to tag individual enum members? Probably not. I don't think so. I don't see really any reason to. I'll put a to-do in here. We want to be able to tag individual enum members. And then bit fields as well. Let's just do the same thing. Wait, where did I put that? These should really be the same function, honestly. Comma closing brace. Wait, why are these different actually? Parse enum member, parse. Oh, I do this a little differently. Here. Okay. So that's variables, functions, structs, unions, type defs. Do we skip the semicolon here? Expect a semicolon, and we skip it. I don't like how inconsistent this is. It's because in some cases, like a variable decal, you expect there to be a semicolon after. But not always. Like if it's a parameter, that's still a variable decal. But in that case, you explicitly don't use semicolons. So in that case, I leave it up to the caller, whoever called it, to handle the semicolon. In all these other cases, they don't. I should have just made the decision one way or another that they all behave that way, but this is where this is the thing. Members struct member. Does that just call parse variable decal? It does, and then it just sets the type after. So I forget, does this does add it, doesn't it? Yes. Okay, cool. So I should be able to go here. It is confused. It is it's one of those things that I started this project before having the full picture, and it has since ballooned into more things. I would really like to, even though I just now got to where it's at, sometime in the future, kind of start this over again. Maybe even in this like DB language at some point, but and it would be a lot cleaner at that point. But it's not that dirty, I'll call it. It's pretty clean right now. Okay, so this member should have a hidden tag on it. Oh, which it already did. I already verified that that worked. So I think we're good. Great. Now the only problem, again, is forcoder does not understand that this is not a normal preproc. So if I do this and I give it a tag, it's like, I don't know what you're doing here. I can put a semicolon there to fix it. Spoilers for the far off distant future. I do plan on using this stuff to make my own editor at some point, and it will be fully aware of all of the metaprogramming and all the cool stuff. That's a ways off though. It's a ways off. That's like long-term goal. I don't even have the like functioning platform layer in here yet. Like I'm still all in on the behind the scenes stuff, but okay, cool. That's tags. And I think that's all the tags. Let me see my to do here. You're not gonna be able to see this at all. Okay, I didn't really write much. Good job, me. I guess the last thing to do is just verify that the metaprogram can see these things. Let's just try to where do we generate struct templates? Struct templates. Let's just see. If node, if decal num tags, let's print the tags. Print tags. Let's print node nicely. You know what? Let's just do it this way. For tag ID is 0, tag ID is less than decal num tags. In fact, we don't even need this. Plus plus tag ID. Let's write output the tag decal tags. What am I doing? Tag ID plus /n. And actually, let's do print node nicely node, and then a new line, and then we'll actually print out this. So all the structs now should show their tags. The metaprogram should be printing out their tags now. I don't have to do the tree stuff. Oops. Okay, now I do want this. if decal num tags. Whoopsie. This is decal. Unfortunate. Oh, did I remove the tags out of this whole file? I did. Doy. Let's put it on. Let's put a tag on here. Small. Medium. Large. And let's put it on a struct template. Oh wait, that's not going to show up. This is just struct templates. So these aren't even going to show up. struct template here. Hello world. Okay, that's not great. It still didn't show up. Generate struct templates for variables per. Oh, that's not where that goes. That's not where that goes. I was confused what this was doing. This is looking for declarations. So actually, what I did before, that would have worked, actually. This generate struct templates is looking for these places where you're instantiating them. This actually would have worked for my purposes here to print them out. Right? Because we're looking for all decal variables, parameters, struct members, and union members. So these are 3 variable decals. And there we go. This is no longer coming from the parser or the codegen. This is the metaprogram finding the tags. Which is great. That was the whole point of doing this. So now, if you haven't seen this in, for example, Jonathan Blow's J language, the whole reason you would want to do something like this is a very simple example that he showed for his game is, so a lot of games have a console, right, that you can plug in commands, and you typically program the commands like in your language to do different things. It can be kind of a hassle to hook all those things up. It'd be cool if the metaprogram could do that for you, and you could have various heuristics for figuring out like ways to mark, like this function defines a defines a console command, for example, and you could do that kind of thing. What's really elegant about his system is you can just write a regular function, like say this is my exit game command. So there's a console command called exit that you can that when you type in the command, it exits the game. It won't take any parameters, and I'll just return, like, I don't know, exit program, right? I'll just call exit program. After this, I can put a tag on this that says, hey, this is a console command. By the way, this function is a console command. And then the metaprogram here can loop over all of your functions, look for the ones that are tagged console command, and generate the code that hooks them up to be a console command. And what's extra cool about his, and I'll be able to do this too, because I know it's a function and I can look at all the parameters and stuff, he does all of the type checking, argument checking, all of that in just by writing this. So like if I just wrote this to take a number, like error code, and say you return the error code, the metaprogram can see that, hey, this function's tagged a console command. It has a parameter, right? That means the console command I go generate, say you're over here in the game console, right? If I type the exit command, and actually you would need a way to tag this for the name. Maybe I can just say, like, after this, the second tag in a console command is the name of the command, so maybe it's just called exit. So if in the game you type exit, and I just hit enter, the metaprogram would have written this function to know that, hey, this function takes an error, or it takes a parameter. In the game, it would know that you didn't give it one. All right, cool. Thanks, Tofu. I'm glad you hung out. I'm about to wrap up myself because this is kind of what I wanted to do tonight. So thanks for hanging out. It's cool seeing you in the stream. So yeah, so the game would be able to, it would write the function to know that the game is like, this command expects a single parameter. So if I just type this in my game and hit enter, I could display an error, or, you know, whatever the case may be. So that's a very simple example. Another example that he uses all the time, which is really cool, is for serialization. So if you want to be able to serialize this struct, it's really hard over time as you add more things to it, if you want it to be backwards compatible with older versions of the struct. You have to handle all these different cases where, okay, what if I'm trying to load one from 3 versions ago, but the data types have changed, right? You can tag these members as, okay, this is part of v1 of this struct, right? And then later on, say I add a count variable in here. Well, I can say that this is tagged as v2, right? all the way down the line. Eventually you've tagged all the versions for these things. And then your metaprogram is generating the serialization code. And it can do it automatically for every version of this struct that has ever existed, as long as you've been tagging them along the way. And then you typically keep some like global const, right? Which version you're on right now. So the metaprogram can be like, okay, we're on version 5. If I see anything that is, you know, and in fact, he even does other things like, actually, do I even support this? I don't, right? That actually is not going to work because I don't, yeah, you can't put a minus in, these are supposed to be identifiers. You can't put a minus in an identifier. So, I realized I just rambled that whole time, but I'm going to put a to-do in here. We currently hard expect identifiers here, so I can't do this cool thing, for example. That's an easy enough fix. I'll just, instead of expecting identifiers here, we'll have to be a little more fancy about it, but that's okay. I have in here, eventually, I will get to it, a do a to-do pass, right? I've built up a lot of to-do debt over the course of doing this stuff, which is fine. It happens. It's a lot of little stuff, but I will do a pass over all the stuff to make it even more robust. That can come later, though. All right, cool, though. We have tags. That's fantastic. If I look at what else I was wanting to do, they're all a little bit more involved, so you know what? I don't like this word, nonce. I need to think of a different word for this. I guess counter, but I don't want to just take everything from C. I guess it's not that big a deal. That'll be an easy thing to do next, is inside of snippets, or not even inside of snippets, everywhere. Instead of using these, I use this line directive, for example, to grab the current line number. The C parser, or C compiler just gives that to you. It'll inject the line number. I can actually do that in the metaprogram, or I can do that on the codegen side to not have to rely on the compiler to do that, which I'll probably do. So that's what this is. As an extension of that, I want to basically get away from macros altogether, like C macros, because as it is explained here, they just don't play well with the rest of my system and the metaprogramming, because inherently a macro is not parsed. It is copy pasted into your code wherever they appear. And I have in my little language here this concept of snippets, which are basically macros, but they are parsed before they are injected. They are parsed as a normal node on the syntax tree and then injected into the tree, which I like a lot better. And I basically want to replace all macros. I just will not allow macros anymore. You'll have to use snippets. But in order to do that, I'm missing some functionality. For example, stringification. So in these asserts, for example, right? Like I want to print the line number. I don't have a way to stringify things in a snippet yet. That needs to be able to happen. Which I should be able to do pretty easily. There's a few things basically, like these directives to get the line function file and stuff, stringifying things, concatenating strings. Yeah, so I just have to do those things, and then snippets I think will be ready for prime time. I can remove all macros from the system entirely and rely solely on snippets, which I think will be better. Yeah, I think that's a good goal to at least start with next time. And then I'll do these two. Let's put these two up top, and we'll say like next time. Backlog. Okay, this file's just for me. It's what I use to keep track of the agenda descriptions and stuff. Okay, well, I started late, but that's okay, because I just wanted to get something relatively small done. Even though this is a big deal, this is pretty cool that these are in here now. Yeah, we can tag our stuff now. That's pretty cool. So I will be back probably tomorrow. I'm going to try and stream every day this weekend. I'm saying that out loud to hopefully means I will do it. So yeah, thanks for watching, everybody, and hopefully you tune in again in the future. Please follow if you're not, if you're interested in what I'm doing here. Yeah, take care. Take care, everybody.